Hey, welcome back to Fat Mama Physics. In this video, we are going to talk about unit conversions, which is a tag along to fundamental and derived units that you've hopefully watched already. This video, I will be showing you how to do unit conversions and how to use something called dimensional analysis, which saved my ass in university when I was doing physics courses, even fourth year courses. You can, if you know your conversion factors, use a little bit of dimensional analysis without knowing the reason why you do certain steps, you can, in the end, get your final answer. I don't advocate for that, but I'm just saying how powerful the tool is and also why it's important to know that for unit conversions. So unit conversions, very important. Side story, I think it was around 1999, before you were born. I don't know if you're, anyways, maybe before you were born. There was a mishap that happened with NASA's Mars Climate Orbiter. So because the system was expecting metric units, and we know the states, they use empirical units instead of the metric system, there was a miscommunication with the units. They didn't convert their units from, I think it was imperial to metric. I have to double check on that one. Either way, without that unit conversion, you slap the machine on, something's going to go wrong in the launch and getting the space shuttle to properly orbit Mars. That was a $125 million project gone to waste. So a typical mistake you're making on the page for unit conversion costed NASA a huge sum of money. You might think that's very stupid. Well, you know what? Sometimes we make these mistakes and sometimes we can't make these mistakes when we're talking about big scale projects or things that can cause things to change by a whole lot. Little one thing you forget changes a whole thing. And very interesting. And some of you who might be going into engineering, not to scare you, okay? Not to scare you. Going into engineering, after you graduate, you might have heard already, might have seen people wearing a ring on their pinky. That is a little small metal ring, and that's to show whenever you're signing something off, that metal ring leaves a mark on the paper that you're signing for a project. So if you're designing a bridge and you screw up, it's a lot of weight when you're signing that paper. So same thing, it's measurements, units, they're very important, conversion factors. That's why we're learning this right now. So let's do it. Now, before we do any sort of do any unit conversions, it's very important to know the conversion factor. And, well, yes, but why, I'll show you in a second, is that when we're going to use these conversion factors a little bit, we're going to manipulate them in a way that's going to help us get rid of units we don't want in our final answer and put in units that we do want in our final answer. Here's what I mean. Let's take a look at number 1. We are going to convert 54.7 millimeters to meters. So the first step is to write out this number. So 54.7 millimeters. Now we're going to go to find the conversion factor. I wrote it here for you, but if you don't remember, it's in your data booklet where you see this table. Okay, so now we're going to write this little conversion factor as a fraction. Okay, as a fraction. So then you might be thinking, well, why is a fraction? First of all, if 1,000 millimeters is equal to 1 meter, then essentially this fraction is going to give me a value of 1. And it doesn't matter if I put meters on top or if I put millimeters on the bottom. Since they are the same thing, they're still going to give me 1. So essentially what I'm doing, I'm going to multiply my original number by this fraction. And since this fraction is essentially equivalent to 1, if I multiply anything by 1, it's the same thing. It doesn't change. So it doesn't matter which one I put on top or on the bottom. But for our purposes, we want to convert this number to meters, meaning we want our final answer to have meters on top. So our conversion factor has to have meters on top of the fraction. So I'm actually going to have to use this guy over here because that gives me 1 meter on top. And here's the cool thing. I need to put the 1,000 millimeters on the bottom. But because I have millimeters on top for my first number, which is essentially that divided by 1, so this is on top, millimeters is on bottom. If I multiply the two, these two cancel out. So I get rid of the units I don't want, and I'm now left with the units that I do want. So now we do the math, okay? And what does that mean? If I multiply by 1 over 1,000, which is essentially what this is, I divide 54.7 by 1,000. So that's moving the decimal place to the left by 3 with the 3 zeros, 1, 2, 3. And I get 0 there and a 0 there. So that gives me 0.0547 meters, okay? So that's how we do the conversion factors. You might be thinking, I know that already. I don't have to go through all these little steps, Miss Lee, that you're talking about. Let's just start with the simple ones. When we get to more complex examples, this is going to be easier for you, okay? It will actually be applicable not just in physics, but in chemistry and your other sciences as well, and you will see that. So let's do another one together. I'm going to pick 3 to do with you, and you can do 2 and 4, okay? So convert 0.92 hours to seconds, okay? So I want to get rid of hours. I want to be left with seconds. Let's go and identify our conversion factor here, which is this one. There is 3,600 seconds in 1 hour. If you don't believe me, go work it out yourself. So I'm going to multiply a fraction, and this fraction is going to have, and I want the fraction to have seconds on top because I want to end up with seconds. And I want to get rid of this hours, so I want the hours on the bottom. So then to put this conversion factor in here, I want the 1 hour on the bottom and the 3,600 seconds on top. So that's what that looks like. And I notice the hours here cancel because one's on top, one's on the bottom. I am now left with seconds, which is perfect, exactly what I need. And now I just need to multiply 0.92 by 3,600. So we can just quickly do that on our calculator. I get 3312. Okay, so there were the 2 examples. Let me give you a chance to try 2 and 4, okay? Good time to pause the video. Okay, I'm going to quickly do 2 and 4 quickly. So the first one is 1.69 kilometers. Did you know there are 1.69 kilometers in 1 mile? Haha. Okay, anyways. So we want this to be in meters, okay? So we start off with writing down 1.609 kilometers. So the conversion that we want to multiply needs to have kilometers on the bottom for us to cancel and meters on top because that's the unit that we want in the end. We want the units meters. So we go to our conversion factor, which is right there. We have 1,000 meters per 1 kilometer. So then the kilometers cancel and we are left with the meters on top. So that is 1.609 times 1,000. We get 1,609 meters as our final answer. Okay, question 4. Convert 1,900 seconds to hours. Okay, hey, I got the answer here. Interesting. Okay, so I'm going to write 1900 seconds. I need to multiply by some conversion factor that is going to get me hours. So I need the hours on top in my conversion factor and seconds on the bottom. So if I go to our conversion factors here, that is 3,600 seconds on the bottom and 1 hour on top. So we do a little bit of division here because here seconds cancel out, we're left with hours, and if it's on the bottom, multiplied by 1 over 3,600 is the same thing as dividing by 3,600. So we quickly do this one. We get 0.527, 0.52777 repeated in hours. I don't expect you to know significant figures right now. There we go. Okay, so that is the basics of converting from one unit to the other. Okay, but sometimes we might have more complex units, like derived units, for example, where you have a fraction and you have some unit on top and a unit on bottom, just like meters per seconds. Then what do we do then? Okay. And then before we do a few examples, I just want to quickly point out that in your final exam, you might see units that look like this. Okay. And what that is this here, you see a negative to the power of -1. That just means the inverse, the reciprocal. So that just means that particular unit is on the bottom. Notice there's a space between the m and an s. So that -1 is just talking about the s. So what that would look like is I would have m on the top and then s on the bottom for the -1. And for all your units that you see on your IB exam, if you're taking an IB exam, that's what you'll see for units. If you don't see per, you don't see the slash ever. So something to get used to. I will use both, depending on the resource that I have, but I try to use more of the ones that you'll see on your IB exam, but just heads up that that's what you will see. Another example here, m and s to the -2, that's just meters per second squared. Okay, so hopefully you'll get used to that over time. Okay, so we got some examples. I will do 5 and 7, and you will do 6 and 8. Okay, so now we have more complex units. For example, 50 kilometers an hour is something that you might see on your speedometer as you are driving, if you are driving right now. So and this question is, it wants meters per second. So for kilometers per hour, I'm actually going to write it like a proper fraction. Like I'm going to write it in the fraction form, so it's more visual appealing to us. Okay, and our final answer, we want it to be in meters per seconds, meaning our conversion factor that we multiply has to do two things. It needs to get kilometers to meters and from hours to seconds. You might notice that we cannot do that using just the one conversion factor. We will probably need two. That is okay. That's okay to have two conversion factors. I'm going to do them all in one step, and it's doable. It's fine. Because you'll notice things will cancel out. For example, kilometers to meters, I need my conversion factor to have meters on top, kilometers on the bottom. How many meters are in 1 kilometer? 1,000. Okay. Next up, we want hours in seconds. So we want, now this is a little different because we're talking about the denominator here. I want seconds to remain on the bottom because that's what the answer that I want shows. And I want hours on top because if I have hours on top and hours on bottom, these two will cancel, okay? And how many seconds are in 1 hour? 3,600. So notice I have kilometers canceling, hours canceling. I'm left with meters on top, seconds on bottoms, meters per seconds. What does that look like in terms of math? This is 50 times 1,000, and this is times 1 over 3,600 is the same as dividing by 3,600. Put that into our calculator. That's 50 times 1,000. Do that first. Divided by 3,600. Okay, I get 13.8888, and I'm just going to write that as a continuous number and meters per seconds. Okay? All right, so that was our first example. So for example 7, there's a typo here. That's kilograms times second to the -1, not -2. It wouldn't make a lot of physical significance there. Okay, so we want 0.55 kilograms per seconds, and that's what the -1 means, and I put them in that format so you can get used to it. Kilograms on top, seconds on the bottom. And we want our final answer to be in grams, and seconds to the -1, that's grams per second. So, hey, look, we have seconds on the bottom, seconds on the bottom. We don't need to worry about seconds anymore. We just need to worry about the kilograms to the grams. So, we want grams on top. We want to get rid of kilograms by putting kilograms on the bottom. We know there are 1,000 grams in 1 kilogram, so that as our conversion factor, the kilograms here cancel, leaving us with grams and grams on top, which is good. We proceed as 0.55 times 1,000. That's moving the decimal place to the right 3 times. 1, 2, 3. So that is 550 grams per second. And if I want to write that in the notation that I have in the question, 550 grams second to the -1. All right, your turn to do examples 6 and 8. Good time to pause the video. Okay, so let's do these ones together. 10.9 meters per seconds, and I want my conversion factor to give me kilometers on top and hours on the bottom. So, I need 2 conversion factors, so let's break that down. So, meters, to get rid of meters, I need meters on bottom, I need kilometers on top. There is 1,000 meters in 1 kilometer. I need hours on the bottom, seconds on top to get rid of the seconds. There are 3,600 seconds in 1 hour. So if I cancel things out, these meters cancel, the seconds cancel, and I'm left with kilometers per hour. Beautiful. So mathematically, that is 10.9 times 1 over 1,000. That's the same as dividing by 1,000. And times 3,600, exactly the opposite as the previous question. So 10.9 divided by 1,000 times 3,600. And I think that is correct. Yes. So 39.24. And our units are kilometers per hour. If I write it in the correct notation, kilometers and hours to the -1. Okay, either one works. Next one, we want 75 grams per milliliter all the way to give us kilograms per liter. So it looks like we need 2 conversion factors here. Here we go. Grams to kilograms. So divided by kilograms and multiplied by kilograms. There are 1,000 grams in 1 kilogram. Milliliters to liters. There are milliliters on top and liters on the bottom. There's 1,000 milliliters per 1 liter. Milliliters will cancel. Grams will cancel, leaving us with kilograms per liter. So, way, that's so cute. Look at this. We multiply by 1 over 1,000 and we multiply by 1,000. So these two cancel out. Yes, we love things that cancel out. So that means we don't need to multiply anything. It's just 1. And hey, look, 75 stays as 75 kilograms per liter. Okay, so that's our final answer. Well then, that's the conclusion of this video. You hopefully learned something about conversion factors and a tool that you can use for life called dimensional analysis. I thank you for watching this video. Good luck with the practices that you do. Fan Mama Physics signing out.